Okay, so today we'll go into the CSA 3 of our lab sessions. So go to the linkpadlet.com CSA 3. So let's start the sessions today. The first one we will look into how to create our own procedure, right? Last time we're using the WIA1003 procedure. We need to call the procedure. So basically the call procedure is very simple. You just need to call the procedure, then you'll go into the subroutine or the sub procedure. Then after they finish, you need to return from the procedure. So let's copy this one. And we put into the Visual Studio. Okay, so when you look into it, this is your dot code area. Then you can start with the subroutine. Okay, when you want to create a the procedure, you just need to give the name of the procedure. So let's say this procedure, I want to put it as a sum of, or any name you want to give. You just put a name, then followed by this PROC, right? Followed by this PROC. Then inside the next line, you can start to write the coding or the assembly code you want this procedure to work on. After done, you just need to put a RET, means a return. When you come into this procedure, you will run the code until the end return. They return back to where you call them. Okay, then the end part is just using the same name of the procedure, same as the beginning, but the last one you're using the ENDP, end procedure. Okay, right? Then this is the same thing, the main procedure, the main part of our coding, right? Every time we code in the main coding here. So when your program start to run the assembly code, they will look for the main procedure. So the first thing they run is this one. They are not going to run this sub procedure, because they will always look for the main procedure when they assemble the program. Okay, so this thing can be put at the top or even at the bottom. They also can be worked. Okay, just out of the main procedure. Okay. You can put it outside of the main, at the bottom of the main procedure also can. Both of them will be good work. Okay, because the program will always come to the main first. Okay, then come to main first, they will look what the code. So the code is move EBX, ECX, they only call the sum of. So means I am going to use EBX and ECX in the sum of. So what are the sum of doing actually? So let's say we go to debug. We stop it here. Then we go to debug mode. Okay, we put it here. So I'm basically moving 5 to EBX and ECX, right? The first two code. Then I will call the sum of. So when I call sum of, they will come to the sum of procedure. But they are not going to show it here. They will just run through the sum of procedure. Oh, wait, I need to add on one more thing here. We restart again. Okay, EBX, ECX, 5, then call sum of. Yeah, so they will come to your sum of. Right? Then they come to your sum of. They will do this. They will run the coding. Okay, move your 0 to EAX. Then just now I moved EBX5, ECX5, right? So basically they are adding these two values in the sum of procedure, and they are using the EAX as the register to do the operations. Then my EAX will hold the results, which is A. Then this is RET. When they come to RET, means they return back. So just now where I will call from here, right? So when they return to the next line. Right, so they return to the next line. Okay, this is how you can create your own procedure. Right, remember the name of your procedure followed by PROC. This is fixed, you cannot change it, you must put PROC. Then you can start to write a code followed by an RET for the return. Then the end of the subroutine, you just put the name back again followed by ENDP. So this is the way to create your own procedure. Okay, so let's go to the next one. The next one, we are starting to look into the stack, how to use our stack. We can use a push and pop to store values into our stack. So we copy this one. So you copy this code and put in the Visual Studio and go in the debug mode. So in the debug mode, we put a breakpoint in your main procedure and also the array sum procedure. So this coding is just the beginning is just moving the offset of the array, the starting location of this array into your ESI. Okay, so step 2, ESI become 46,000. Then the second one is just to move the how many elements, the length of this array into ECX. So it should be 5, right? There's 5 elements there, so 5. Then a call down rec is just display the register. And the next one, I start to call the subroutine functions, array sum. Okay, so the array sum is basically just to help you to add up the total values of all the elements here. Okay, so let's say I call array sum, then you will come to my array sum. So before I start to do the functions in my array sum, what I did is I want to push my ESI and push my ECX into the stack. So when I finish this array sum coding, I will pop them back from the stack. So push is to put the values into the stack. Pop is to get back the values from the stack. So before I push, so you can see the ESP is a stack pointer. They are pointing to FF70. So when I push, it will reduce, right? 70 becomes 6C. Then when I push again, it becomes 68. Okay, so basically they are storing the values into the stack already. So let's say you want to know, you can just copy this one and go into your memory and check for it. 0x 0. Okay, so this is the values inside your stack. Remember, you are storing 00, 40, 6,000, right? Then you store 00, 05 in the stack also. So you are storing your 46,000, 00, 46,000 here, and also the ECX values into the stack, right? So the stack pointer has been come to 68 now. Okay, so they point to 68 now. So in the next one, they will go up and store if you have push extra thing. Okay, so then after that, my ECX haven't changed yet, my ESI also haven't changed yet. Then I'm starting to go into the loop of array sum. So what happened in the array sum is I starting to using my ESI and also the ECX also. I'm using loop, so my ECX will reduce every time I go out from the loop. Then I'm using the ESI plus with the types of array means +4, so that I go to the next element. Since my array is a D word, so I need to +4, so I can go to the second array, second values in the array every time in the loop. So then I loop again, then my ECX become 4, and my ECX change already, right? Until my ECX becomes 0. Yeah, so at the end I already add everything into my EAX already, right? The sum already in the EAX. Then what happened? My ECX and ESI already changed. They are no longer the values which I have before I come into this sub procedure. So what can I do is I can pop the values back from the stack. So now the stack is here, then I will pop. So let's say I do the pop ECX. Remember, the stack is last in, first out. So ECX is the last thing I push. So when I want to come out, I must get the ECX first, because my stack now is pointing to the values of ECX store. So then when I pop, look at ECX, now it's 0. So when I pop my ECX, I get back my ECX initial values. The next one I will pop ESI. So I get back the ESI values. Okay, then only I return. When I return, I come back to the next line. Right? So this is the methods of using push and pop. Before you go to a sub procedure, you want to store the important values of some of the register, you can using push and pop. Okay, so this is the way of using push and pop. So just now we are using our manual coding to use a push and pop. If you don't want, you can using this one also. Okay, using the operator name users. Okay, you are going you put this thing in, then you don't need to you do this push and pop in the sub procedure. They will automatically do it for you. So let's say I copy this one and I add it into my sub array here. Let's see what happened. Can I move this thing out? Okay, I delete the push and pop, and let's start over again. Okay, let's start over again. Then let's try. I'm missing the dot here. So let's do it again. Start debugging. Okay, then I go into my ECX is still 5, 4, 3, 2, 1, and ESI also change. So when I return, so I'm going to return. So when I return, let's see whether they pop it back or not. See, they will pop it back for you automatically. So you can using this operator users, then you just type in the register you want them to pop for you and push and pop for you before they start using and after they use the array, right? So they are the same. Then there's also another called push AD and a pop AD. So they will automatically pop and push all this register for you. If using AD, means they will push all this register A, C, D, B, EBP, ESI, and EDI. This is the 8 register. They will push for you. If you're using push AD, so they will automatically push all these 8 register. Okay, so we go to the next one. Yeah, we also can push our flag also. Okay, we can push the status flag into the stack also by using push FD. Okay, then there's another example of a pop and push. Let's try this one. Is it whole thing? No, it just so I copy it here. Dot data, right? Then okay, then this thing can be deleted. Okay, so this coding is basically, let's see how it's working. Delete this one. I have a byte or a string called Abraham Lincoln. Then this name size followed by this symbol the dollar symbol. So the dollar symbol is basically getting the current location counted. So this A name, let's say they are at 46,000. So then this A name is the location values after the 0 here. Okay, so let's say I just have 2 bytes. How to? Okay, so let's say I have 2 bytes only. 1 and 0. This is the 2 byte I have. So this is the 46,000. Then the next locations will be 46,001 is this one. Then the name size, if I using this symbol will equals to 46,002. Okay, 46,002. Okay, 46,002, which is the current location. After this 0, the location is 46,002. So basically this symbol is meaning the next location values. Okay, so what they did is basically I have Abraham Lincoln's, then I need to know how I want to know how many bytes is this thing have. So what can they do? Because they are not an array, we cannot using the normal the type and also the length of, we cannot using a length of to get the number of array elements inside the array. They are a string. So the way we can do it is using this symbol, then we minus this one. Okay, let's say we know the number after this address location after this array, and with the 0 is using this symbol. I think I need to using, hold on. Okay, so let's look into this one. Your Abraham Lincoln. Okay, so this is the array of Abraham Lincoln. So this is they are in terms of byte, right? So let's say they are starting at 46,000. Then this is store your A. Then the next one is your B. Consider them in ASCII code. So there should be a certain number. I cannot remember what is the number here, so I just put the character here. Okay, so if A, if I'm not mistaken, it should be 41. So it should be 41 storing at this location. So I just put the YuEm, right? Then followed by a space. So this is a space. LINCOLN. Followed by the 0, right? Okay, I think I cannot see this. I write it smaller a bit. NCOLN 0. Okay, so this is your array. So this is 46,000. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. Okay, so this is the total address location. So this should be 46,000 F. Okay, then basically the next one is pointed by this symbol value. Okay, the next location, when I'm using this symbol here, which means the next location value is if it's with this symbol. So the symbol should be equals to 46,000. Sorry, this F already, then they will increase by 1, 0. So this is the number of this dollar symbol. So I hope you're clear. So this is the way the symbol used. So the symbol is equal to these values. So from here we can using this one to minus so they're using dollar symbol to minus the A name. So which means they are using the next address location to minus the 46,000. This is in hexa, okay, hexa value. So from here, then we can know how many elements we have in this string, right? But they minus one more extra one. Why? Because they want to minus out the 0, right? So they minus 1. This is to get rid of this 0, right? So from there they can know the size of this string, how many character inside the string. So this is how the way they get the string, the number in the string. Then they bring in the thing. Let's start. Okay, so they start to move the thing into the string. So from there, they know your ECX equal to F, right? It's same as the one we calculated just now. There are total 15 elements here. From 0 up to E is equal to 15 elements. So yeah, so that's equal to F, right? From 0 up to E, they equal to F. 15 elements, so they move into ECX. Then they move 0 into EXI, then they offset the name, so they get the starting location into the EDX. Then they call the right string, so it means they write out the Abraham Lincoln here, okay? Then they space one line, then they start to do the reverse process. They will get the first values in the array. Okay, this is the index operand, how they do the move values into the EAX. So A names, then followed by ESI. So ESI is 0, so means I get the first values of the array. So I get the A, Abraham, the capital A. From here, I move into EAX. So EAX become 41, right? The A, capital A. Then I push it into the stack. I push them into the stack. The A will go into the stack. Then I increase my ESI into 1. Then I loop back again. So it means my ESI now is 1. So it means I will move the next values, which is the Abraham, the capital, the small letter B, which is 62, right? Then I move into A, then I push them into the stack again. I keep on doing this process for 15 times until I move all the thing into the stack. Is it done already? Okay, done. Then I will come to the next line, which is I do the same thing again. I set my ECX to 15 again. Then I reset my ESI to 0 again. Okay. Yeah. So if let's say I don't want to do this line, what can I do? I can using the so this is not procedure, so I cannot do that. Okay. So after I reset to 15, then 0, I start to pop. I start to pop out the thing. After I pop, I store it in the first location. Clear? So this is your value array, right? Then what I did is I just push them into the stack. So this is your memory. Okay, then this is your stack. Basically, this is also inside your memory also. But this is the way you store your data. Then in the first coding, first part, you just push this into the stack one by one. So at the end, this thing will come to your stack also. So Abraham space Lincoln COL. Okay, so I push all these things into the stack. So now when I want to pop up, this is the first thing going to be pop up. But after I pop, where is the location I store? I store it at the first location. I store it at ESI equal to 0. I store at the first location. Means I'm going to bring this thing and put it into here. So the A will become small letter n. Then the second one, I will keep on loop, right? I will keep on loop in the program. Then the L will come to here. This will become L. Then the O will come to here. Okay. So after one round, I will inverse the string actually. Right, after run this thing for 15 cycles. Then I offset the A name again. I want to write out the string in the display window again. So let's say come here. So now it still haven't displayed out. I will call the right string. When I call the right string, they display out. They already inverse the values, the string for you, right? So this is the way they're using push and pop to invert the string. Okay, so this is one of example. They're using push pop to do this. Okay, and one more thing, your push and pop, they only can work on 16 and 32 bits operation only. If you go to byte, they will give you the invalid instructions. Okay, you only can push and pop something which is 16 or 32 bits only. Okay, then this is an example of using push and pop to inverse this string. Okay, so this is all the example we have for the push and pop. The next one, we are starting to the logical operations. Okay, the first one is very simple example using the AND. In logical, we have AND, we have OR, we have NOT, we have XOR. Okay, so let's try the AND symbol. When this logical, they're in terms of bitwise. They are in bitwise, so means they will work in the bit operations. They work in bit operations, so let's copy and this one and come to here. All this thing. And operation. Okay, let's do it right down here. Okay, so I come to this one. So I have a string A until G in a small letter, right? Small letter. Then the same thing, I using this one to get how many string inside, but this one I have a 0A and 0 here, so I need a -2. 0A I think is a carrier return, or yeah, added carrier. There's a A and D, one is carrier return, one is a new line. Okay, so I have a 2 extra byte here, which is I don't want, so I -2 here. Okay, so from this one I can get how many character I have in this string, so it should be 7 character, right? So I'll move the name into C, so my C becomes 7. Then I move my ESI becomes 0. Then the offset and a display, call the right string. I don't know why it's restart again. See. Okay, so let's try. Okay, so they display out the ABCD and G after you call the right string. Then the next one is come into the loop. The loop means they bring in the first values in the string into AL, right? The ESI is 0, then plus with this one is the first values. So you bring the first value into AL. Then after that, do the AND operation. The AND the first value AL is 61 now. They bring in 61. Okay. Your is A, B, C, D, E, F, G, right? So this A is a 61 now. In hexa value 61, which is mean 6, 1, right? 61. So they end with 1, 1, 0, 1, 1, 1, 1, 1. So what will happen? It will become, if I do the AND operation, just do the AND. So 1, 1 equals to 1, 0 becomes 0, 0. So they get back the thing here. Then this thing become 0. This become 0 also. So this is 1, this is 0. So it become, this is 41 in hexa, right? From 61, the change become 41. So 41 is equals to hexa value, capital letter A. Then they repeat the same thing. Your B, I think, should be 62. 1, 0, right? Then they end with 1, 1, 0, 1, 1, 1, 1, 1. So everything end with 1, you'll get back your same value here. Then so this is 0, this is 1, this is 0. Then this thing, when you end with 0, for sure it becomes 0. So same thing here. So basically the operation is just to change this bit into 0, so that you can change from 6 to 4. This is 61, 62, 63, 64, 65, 66, and 67. Okay, then this one become 41, the capital B become 42. Right, so after you look the process, they basically convert the small letter to big letter. Right, you see the process, you see in the AL register, 44, the next one is 65, become 45, 66, become 46, after AND operations, 67, after AND operation, become 47, right? So this is just to, from small letter to big letter. Then after that, I display the string again. Yeah, so I become capital letter already, right? This is the way how they change using the AND operations. Change from the just change one bit to 0. So any bit you want to make them becomes 0, you can using the AND and set the bit to 0. Okay, so this is an AND example. Then we can using the test example also. Test is same as an AND, but the difference is AND will change the values inside the register, but test they won't change the values inside register, but they will change the side bit. Okay, let's do something. Go back to this one. Then we change the AND to test. Okay. Then we call dumrex. We call the dumrex. So let's say AND with 0. Okay, I end the thing with 0. At the end, it will become 0, right? So this is test. So I start with AND first. Okay, I try with AND first, then we see what happens. we can just stop the debug. We can just run the code. Okay, start without debugging, then it will run the code for me. Okay, we run again, sorry. Start without debugging. Yeah, so they will display all the thing for you, right? So every time I end with 0, the 0 flag will set to 1 because I get the 0 values. So the 0 flag will set to 1, right? Then what you can see, your AL also have been changed because I end with 0, so my AL becomes 0 also, right? So my AL becomes 0 if I'm using the AND. So let's try with the test. If I end with 0, what happened to my AL? I do it again. Okay, so I'm using a test. My 0 flag is set also, but what do you see in here? My AL won't change, they will remain the value. Okay, just now using AND, they will change my destination values, right? They will put the AND result in the destination values if I'm using AND. But using test, my AND values were not affected. They'll remain, my destination value will remain the same without change. So this is the difference between AND and test. Basically, they are both the same operations, but test does not alter the value in the register. Okay. So the next one is OR and NOT. It's just a simple, the same thing. They will do the OR operation and NOT operations. We are not going to go through. Then for the XOR, so the XOR example, copy into your Visual Studio. Basically, your XOR, they are able to help you to check the parity. So if this is the values, so this is odd parity, is it? Number 1, 1, 2, 3, 4, 5. There's 5 1 in this 8 bits of data. So they are actually in odd parity. So when I XOR with AL with XOR these values with 0, it will set the parity flags to 0 if it's odd parity. Then the next one is even. I do the same thing. I XOR it with 0. It will set the parity flag to 1. Okay, so this is even. 2 1 2 1 here, so it's even. So let's debug and start without debugging. So you can see here the parity flag. Yeah, this is your parity flag, this one. So for the first one is odd, it will be 0. The second one is even, it will be equal to 1. So if you want to check a byte of data is in odd or even parity, you can using the XOR. The XOR will tell you is it even or odd by setting the parity flag. Okay, so this is how they get the values by using the XOR, even, and parity check. Then the next one is set STC, set carry flag, and CLC, clear carry flag. So this is just two instructions where you can set and clear the carry flags in your status flag only. Okay, you can try this one by your own. Then the two examples, set intersect and set union, is just to show the AND and OR operations. For set union, they're using OR. For set intersections, they're using AND. So which means if you want to get a 1 from the AND function, you must get both is the same. Then for OR, either one is 1, then you'll get the result as a 1. So it's just to show the OR and AND in these two examples. You can try to go through. Then the next one is come to the compare to the last one. Yeah, this should be the last one. Then bottom part is all the example. You can go through the example code. And the last one is comparison. CMP, compare. compare means they will compare two values, right? Then they are affecting the status flags. So you can using jump followed by the compare. So this is your example. Let's say I move values. So let's try put into your this one. Okay, clear everything. Move it to L1. So we must have L1. Okay, move 7 any values. Okay, just to have L1. Then okay, so I move something into my EX. Let's see. Okay. So the jump, example of the jump. So I move something into EX. So my EX become 5. Okay, my EX become 5. Then I compare my EX with the 5. Okay, I compare my EAX with the 5. Then I will jump if both of them is equal. So after I compare, the status flag has been changed. So the jump is always follow this status flag. So there should be equals to the 0 flag should be equals to 1. If they're equal, then they will jump to L1, right? So they will jump to L1. So they won't do this coding, right? EX7. So let's say I restart again. If I compare it with, sorry, I haven't changed the code. Compare something with others. Which is 4. I think I need to call the dump rack. Cannot. So I just try this one. Okay, compare. They will jump to L1 if it's equal. So since it's not equal, 4 and 5, they will not jump, right? They will move to the next line. So this is the functions using the compare followed by the jump. So the CMP is just a comparison. Okay, then go back to here. So this is compare, then it's jump if less than, then it also can jump if greater than. Okay, so this is the compare functions. Okay, if a destination is less than source, then yeah, I can do this one. This one better example. Okay. Let's see. Stop debugging. I just start without debugging. Okay, I just start without debugging. Okay, so this is the first code. First code is I compare with 5 and 10. Okay, the first destination is less than source. The destination is your AX. The source is the next second operand. So your source is 10, then your destination is 5. So if you do the comparisons, the destination is less than source, your 0 flags will be 0, then the carry flag is 1. Okay, so 0 flag equals to 0, your carry flag equals to 1, right? So this is the comparing result. Then if it's both is equal, your carry flag is 0, your 0 flag is 1. So 0 flag is 1, your carry flag is 0. Okay, then if you're using the last one, destination is greater than your source. Your destination 105, your source is 0, so it's greater. Both of them equals to 0. Carry is 0, 0 flag equals 0. Okay, so from here we can know basically the compare is just doing the subtractions, right? They're using 5 minus 10, so it's not enough. You need to have a carry. You need to carry something, carry from the next one to get to minus 10, so you need a carry. So that's why a carry flag is set, and the result is not 0, so that's why it's ZF. Okay, so that's why is this one. Then equal, if it's equal, then the end result is equal to 0, so that's why a 0 flag is set. Then you don't need any carry. The last one is greater, you're minus something less than you, so it for sure is 1 0. It will have a positive result. Then it also don't need the carry. So basically CMPs do the subtractions, but it's same like the AND and test. For CMP, they won't affect your AX register. Your AX register is still remain the same. Okay, 0, 5, then this is 1000, right? E 1000. Then this one is a 105, right? So this example of compare and a jump. So I think that's all for this CS3 sections. If you have any questions, you can just post in the spectrum. So I think that's all for today. Thanks.